Welcome to the ftir.fun Infrared Learning Series. This episode, Ep16 Sample Preparation Practice and Common Mistakes. Then close with a checklist. Next, IU, the birth of a ghost spectrum. One Friday afternoon, a novice named Xiao Li rushed into the spectroscopy room with a freshly made K per pellet. The spectrum appeared. Why is there a big peak at 3,400 cm? He thought it was a hydroxyl group from the sample, but upon comparing with the standard, it didn't match at all. Similar ghost spectra occur almost daily in infrared labs. Next, solid sample preparation practice. Solid samples are the most common form in infrared analysis, with main methods being the pellet method and the hydroxyl. This section focuses on the K-pellet method transmission. Data preparation tips are in section 4. 1.1 K-per pellet method, the classic. Next, i.e. liquid sample preparation in practice. The core of liquid sample preparation is selecting the appropriate path length cell. Improper path length leads to two typical problems. Too long causes flat top absorbance 2. Too short causes poor SNR. Structure, 2 windows plus spacers, lead KL. Next, IN. Aqueous samples, challenges and strategies for water peaks. Water is one of the biggest enemies in infrared analysis. It has extremely strong absorptions at 3,400 centimeters and 1,640 centimeters, with absorptivity far exceeding most organics. 3.1 Infrared absorption of water. Next, IV. Common mistakes in X-ray sample preparation. Although X-ray requires no sample preparation, some pitfalls can severely degrade spectral quality. Symptom: very weak full spectrum signal 0.1, extremely poor SNR. Next, top 10 common error spectrum case studies. Below are 10 most common mistakes made by beginners, each with error spectrum illustration, pause analysis, and remedy. Case 1: K-per not fully dried, 3,400 1,640 ghost peaks. Next, errors spectrum RV, correct spectrum comparison. Case B, liquid cell measurement. Next, the meaning checklist must check before measurement. Before each measurement, check against the following demining. Checklist 1 by 1. Action. Comment has been on greater than or equal to 30 minutes. Source stable Eb desiccant. Effective, silica or gel not turned pink. Instrument purged greater than or equal to 15 minutes, if coal and water vapor. In to be subtracted, detector pre-cooled, MCT detector, means liquid nitrogen. Next, special requirements for quantitative sample preparation. If quantitative analysis, e.g. content determination, is to be performed, sample preparation requirements are higher. 8.1 K browse, quantitatives. Next, sample preparation tools and consumables list. A gate mortar, diameter 50-75 mm, stainless steel statue. Analytical balance, accuracy 0.01 mg, pellet press, 10-15 ton. Paper pellet die, 13 mm, 7 mm, vacuum pump, connect to die for. 9.2 Liquid cell consumables. Next, objective evaluation of sample preparation quality. 10.1 Spectrum quality check indicators. A good infrared spectrum should meet TICAIM. Next, review questions. Novice Niaoming made a K-pellet for the first time, and the spectrum showed a large broad peak at 3,400 centimeters. List 3 possible reasons and explain how to identify which one. You need to determine the ethanol content in a 5% ethanol water. Solution: design a sample preparation plan and explain why the K-pellet method is not used. Finally, the drill actualists. Make sure you can recall each item. Key knowledge point. Key point: paper drying, 150 degrees C vacuum overnight. Store in desiccator. Sample K ratio 1:101, 200. Strong absorption 1. 500. Weak absorption 1. 50. Grinding particle size 2 micrometers. Scattering $I prop 2. P-3. Long air at $4. Pellet requirements: a transparent, crack-free, thickness 0.51 mm. Liquid cell path length, pure liquid 0.0250.1 mm. Dilute solution 0.51 mm. Window for aqueous samples. Health bath zines cannot use Cabru-Nakia. Strategy for aqueous samples. A-tier preferred. Long short path lengths. EO substitution. Water ghost peak positions. 3400, NOS H 1640, H 550 700, bending. As contact, grinding, flattening. Pressure 3 key factors. 10 common mistakes. Cabru moisture too much, little sample. Poor grinding. Poor ITRA content. It's the mining checklist. 5 categories. Instrument. Sample HA. Background acquisition. Quantitative requirements. Precise path length. Reproducible conditions. Multiple replicates. That covers the required sample for this episode. Practice with real spectra on ftir.fun and continue with the next lesson.